All right, today we're putting on our detective hats. We're about to investigate one of the biggest, most profound mysteries in all of science. And believe it or not, the first clue is found in something you'd see every day in a hospital. Let's get into it.
I mean, really think about that for a second. General anesthesia. You breathe in this carefully mixed gas, and in just a few moments, your entire world, your thoughts, your memories, your very sense of you just fades to black. And then it comes back. How is that even possible? What kind of switch is being flipped inside our heads?
So, for well over a century, we've had these amazing molecules that can reliably and thankfully, reversibly, just switch off consciousness. We know that it works, obviously, but the how, the actual mechanism for how these little molecules can produce such a profound effect, that's been a total black box. This is our central mystery, and the clues to solving it could rewrite everything we thought we knew about what a mind even is.
So, our first line of inquiry has to start with a really basic question. What is the mind? For a long time, the leading theory was that the brain is just this incredibly fancy, squishy computer. And your consciousness? Well, that's just the software running on the brain's hardware. But is that really true? Let's follow the evidence.
Think about it this way. A computer, a formal machine, is a master at following rules. You give it a set of instructions, and it will follow them perfectly to prove statements. It's amazing at that. But the human mind, well, it does something else. It has these flashes of genuine insight. It can understand that something is true even without a step-by-step proof. And that little difference, that's our first big clue.
And this leads us to an absolute giant of mathematics, Kurt Gödel. His incompleteness theorem is, frankly, mind-bending. He proved that for any system of rules that's consistent and powerful enough to do basic math, which, by the way, includes every computer program you could ever write, there will always be statements that are true, but that the system itself can never prove. The computer is trapped by its own rules.
And here is the real kicker, straight from Gödel himself. He believed that we humans can do what the machine can't. We can step outside the system, look at that unprovable true statement, and just see that it's true through insight. That leap of understanding is something a machine by its very nature can't do. And this strongly suggests our consciousness is doing something that isn't just computation. Our mind is not a machine.
Okay, so if the mind isn't just software, what about the hardware? Our investigation now has to pivot. We've got to look deeper into the physical brain, way past the usual suspects, to find out where this non-computable magic might actually be happening.
So the typical search for consciousness always starts here, right? With the whole brain. We map its 86 billion neurons, trace their connections. The thinking is, hey, if we just figure out the wiring diagram, we'll figure out the mind. So we zoom in. We look at the neuron, the basic cell. The standard model says consciousness just sort of emerges from all the electrical chatter between these cells, all the zaps and firings and chemical signals.
But our detective work is telling us the answer isn't on the surface. We have to go deeper. What if all that electrical noise is just the end result of something way more fundamental, something happening deep inside the cell's very architecture, its internal skeleton?
And here it is. Meet our prime suspect, the microtubule. These are tiny, tiny protein tubes that form the skeleton of our neurons. They give the cell its shape, they act like little highways for molecules, and, according to a really bold theory, they might just be the processors for a biological quantum computer.
This brings us to the main hypothesis we need to investigate. It's a theory called Orchestrated Objective Reduction, or just Orch-OR for short. It comes from the brilliant minds of physicist Sir Roger Penrose and anesthesiologist Stuart Hameroff. And it's a radical idea that says consciousness isn't happening between neurons, but at the quantum level, deep inside of them. So let's break this down. The Orch-OR theory basically says that inside these microtubules, you have these tiny quantum vibrations that are existing in multiple possible states all at once. That's quantum superposition. Now, when these quantum vibrations reach a certain point, they spontaneously collapse into one single definite state. And that very moment of collapse, the theory says that is a moment of conscious experience.
And right here, this is where it all snaps back to our original mystery. So how does Orch-OR explain anesthesia? Well, it's actually incredibly simple. It turns out anesthetic gas molecules are the perfect size and shape to slip into little pockets inside the microtubules. And once they're in there, they're like a wet blanket on a fire. They physically stop those crucial quantum vibrations. No vibrations, no collapse, no consciousness.
Wow, right?
It's a beautiful theory, but a good detective needs more than just a theory. You need cold, hard evidence. For years, this idea was super interesting, but it was really hard to test. Until now. In 2024, a team of scientists designed a truly brilliant experiment to finally put this whole microtubule idea on trial.
The way they designed this was just so elegant. First, they took some rats and timed exactly how long it took for them to pass out under a common anesthetic. Easy enough. Then, they gave the rats a drug called epithelone B. Now, the only thing this drug is really known to do is bind to microtubules and make them stronger, more stable. And then, they anesthetized the stabilized rats again. The question was so simple. If you beef up the microtubules, does that change how the anesthetic works?
And here it is. This is the smoking gun. The rats with the stronger, more stable microtubules took, on average, 69 seconds longer to lose consciousness. That's more than a full minute. This wasn't some tiny little fluke. It was a huge, undeniable result. It's the first real hard evidence we have.
I mean, you can see it plain as day on the chart. By physically reinforcing the exact structures the Orch-OR theory points to, the researchers made the rats more resistant to losing consciousness. It's a direct physical link. Case closed, right? Well, not quite. Because what this verdict implies, it ripples out way, way beyond the operating room.
If this experiment really holds up, if consciousness truly is a quantum process humming along in our microtubules, it completely changes our place in the universe. It suggests that our minds are tapped into some deep, hidden layer of reality that we're just beginning to understand.
See, the laws of quantum mechanics aren't just for brains. They're the fundamental operating system of the entire universe. And if our conscious moments are linked to these quantum events, as the theory suggests, then maybe consciousness isn't something our brains create from scratch. Maybe it's woven into the very fabric of space-time itself.
And this leads us to a mind-bending philosophical idea called pan-protopsychism. Now, don't worry about the big word. The idea is simple. It's the view that a basic, raw form of consciousness isn't something special that brains make. Instead, it's a fundamental property of the universe, just like mass or electrical charge. It's everywhere.
This completely reframes what a brain even is. Maybe the brain doesn't generate consciousness at all. Maybe its incredibly complex quantum structure, with microtubules at the center, is actually acting more like a highly sophisticated antenna. An antenna that tunes into and orchestrates this fundamental cosmic consciousness into the rich, personal experience that you call you.
And this is really the ultimate implication of our entire investigation. We started with a simple question about medicine. We followed the clues into the quantum realm, inside our own cells, and we ended up here. We've arrived at the staggering possibility that us, our awareness, is just a manifestation of the universe's most basic laws.
So, we end our investigation with a final question, and this one's for you to think about. We've followed the clues from a simple gas to the limits of logic and into the quantum world buzzing inside our neurons. The evidence suggests your mind is so much more than a computer, and your consciousness is so much more than just brain activity. And if all that is true, then what does that make you?